So we look at cost in the short run now. Firm's cost. We look at cost in the short run now. A firm's cost of production will depend on the factors of production it uses. The more factors of it uses, the greater will its cost be. The more factors it uses, the greater will its cost be. More precisely, this relationship depends on two elements: the productivity of factors, which means the greater their physical productivity, the smaller will be the quantity of them required to produce a given level of output, and hence the lower will be the cost of that output. In other words, there's a direct link between TPP, APP, and MPP and the cost of production. The price of the factors is another element. The higher their price, the higher will be the cost of production. In the short run, some factors are fixed in supply. Their total costs, therefore, are fixed in the sense that they do not vary with output. Rent and land is a fixed cost. It is the same whether the firm produces a lot or little. The cost of using variable factors, however, does vary with output. The cost of raw materials is a variable cost. The more that is produced, the more materials are used, and therefore the higher is their total cost. Total cost now. The total cost total cost as I said for production is the sum of total variable costs and the total fixed costs of production. So look at this now. Let's consider table 5.2 and below and figure 5.2. They show the total cost for firm X of producing different levels of output. And examine each of the three cost curves in turn. So you have total fixed cost, so variable cost you have total fixed cost is fixed, right? You can pause the video right here for me, please. Pause the video right here. You can pause the video, draw this diagram as well. Alright. Thank you. Alright. Total fixed cost now. In our example, total fixed cost is assumed to be $12, right? Since this does not vary with output, it is shown by the horizontal straight line, which is from here across to here, right? Good. Total variable cost now with a zero output, no variable factors will be used. Thus, total variable cost is equal to what? Zero. The TV, and since this is the case now, the total variable cost curve therefore starts from what? Origin of zero. With a zero output, no what? Variable costs, no variable factors will be what? Used. That's why the variable cost is what? Zero. Alright? And please note, this is what is used to draw the curve. Alright? Total variable cost, total cost. The table is used to draw the curve. Alright? The shape of the total variable cost curve follows from the law of diminishing returns. Initially, before diminishing returns set in, total variable cost rises less and less rapidly as more variable factors are added. Take the case of a factory with a fixed supply of machinery. Initially, as more workers are taken up on the work are taken on, the workers can do increasingly specialist tasks and make a fuller use of capital equipment. This corresponds to the portion of the TPP curve that rises more rapidly up to the point of what? B. What is the TPP curve? Right here, up to the point of what? B. and B is the long line going up. In figure 5.1. Alright. As output is increased beyond point M in figure 5.2, which is right here, because it's figure 5.2, right? As you can see. Diminishing return setting. Since extra workers are producing less and less extra output, the extra units of output they do produce will cost more and more in terms of what? Wage costs. Thus, total variable cost rises more and more rapidly. The total variable cost curve gets steeper. This corresponds to the portion of the total physical product curve that rises less rapidly between points B and D in figure 5.1, which you have seen before. Right here, between B and D. Notice. So as you have seen right here a while ago, that's it. And the TPP curve corresponding becomes a steeply sloped, right? The point D is reached. When point D is reached, wheat output is at a maximum. Is at a maximum. The land is yielding as much as it can. Any more workers employed after that are likely to get in each other's way. Alright, as I was, alright, so we would have finished total variable cost a while ago. Alright, total cost now. Since TC equal to TVC plus TFC, the total cost curve is simply the total variable cost curve. Simply the total variable cost curve shifted vertically upwards by what? $12. As you can see right here. Look at average and marginal cost now. Average cost is cost per unit of production, which is equal to total cost divided by quantity. Thus, if it costs a firm $2,000 to produce 100 units of a product, the average cost would be $20 for each unit. 2,000 divided by 100. Like total cost, average cost can be divided into two components, fixed and variable. In other words, average cost equals what? Average fixed cost, which is average fixed cost is equal to total fixed cost divided by those average variable cost. Average variable cost is equal to total variable cost divided by quantity. And so average cost is AFC plus what? AVC. Marginal cost now is the extra cost of producing one more unit. That is the rise in total cost per unit in output. So MC equals change in total cost divided by change in what? Quantity. For example, assume that a firm is currently producing 1 million boxes of matches a month. It now increases output by 1,000 boxes. Change in quantity would equal to 1,000. As a result, its total cost rise by what? $30. Now the change in total cost is what? $30 in this case. What is the cost of producing one more box of matches? What they're really asking is to find the what? Marginal cost. Which would be change in total cost divided by what? Change in quantity. Which would be $30 divided by 1,000 will give you what? 3 cents. $0.03. Note that all marginal costs are variable, since by definition there can be no extra fixed costs as output rises. Given the total fixed cost, total variable cost, and total cost for each output, it is possible to find derive the average fixed cost, average variable cost, average cost, and marginal cost for each output using the above definitions. For example, using the data of table 5.2, which is this data right here, which is this one, right? Using the data of table 5.2, table 5.3 can be what? Constructed. So this table that you have 5.3 was constructed based on what? Table 5.2. Alright. This is total fixed cost. Average fixed cost is what? Total fixed cost divided by quantity. So it will be, for this case, it will be 0 divided by, so sorry, 12 divided by 0 give you 0. 12 divided by 1 give you 12. 12 divided by 2 give you 6. 12 divided by 3 give you 4, and so on. Total variable cost is coming from the table in 5.2. Average variable cost would be total variable cost divided by quantity. 0 divided by what? 0. 10 divided by 1 give you 10. 16 divided by 2 give you 8. 21 divided by 3 give you 7. 20 divided by 4 give you 7, and so on. Alright, so you calculate average variable cost. Total cost now is what? TFC and TVC. And then average cost now would equal to total cost divided by quantity. In this case, it will be 12 divided by 0 give you 0, 20 divided by 1 give you 22. Or you could have added what? Average fixed cost and what? Average variable cost to get you the what? Average cost. Good. Alright, so 28 divided by 2 give you 14, 32 divided by 3 give you what? 11. That's for average cost, right? And so on. Marginal cost now. Please note that the 10 is really between what? 0 and 1. Okay? The 6 represent between what? 1 and 2. The 5 represent between 2 and 3. The 7 represent between 3 and 4. 12, 4 and 5. 20, 5 and 6. And 31, 6 and 7. There should be in between them, alright? So this 10 now is where total cost change from 12 to 22 is 10. The difference between the total cost at 0 output and the total cost at when one worker is one output when one is when one output is created and the output is created is $10, right? And so on. That's why I get the change difference between what? The two quantities in this case. Alright. So between 12 to 10, 22 is 10, right? 22 to 28 is 6. 28 to 33 is what? 5. 33 to 40 is 7. That's how you get it. And and then you divide the change in output by the what? Change in total cost, which in this case would have been 1. So you divide 10 by 1, you get 10. Between 1 and 2 you get is change in output is what? In quantity, change in Q is 1. So you divide 6 by 1 and you get 6 and so forth. Alright. Notice that the figures for M marginal cost come in the spaces between one each level of output. Alright. What will be the shapes of MC, AFC, AVC, and AC curves? These follow from the nature of MPP and APP curves that we'll look at in 5.1 above. You may recall that the typical shapes of APP and MPP curves are like those illustrated in figure 5.3. See them here? This is it. Alright. This now This is a sketch, just like that. But this now it comes from the table above, right here. So, all right. The shape of the MC curve follows directly from the law of dimini- diminishing returns. Initially, in Figure 5.4 above, as more as more of the variable factor is used, which is used, extra units of output cost less than previous units. MC falls, meaning marginal cost falls, right? Go again. As more of the variable factor is used, extra units of output costs less than the previous unit. This is a variable factor, friends. Alright, so as more is used, as you see, marginal cost get what? Less and less, right? At first, right? This corresponds to the rising portion of the MPP curve in figure 5.3 and the portion of the total variable cost curve in figure what? 5.2 to the left of point M. You can go back and look at it for yourself. Beyond a certain level of output, diminishing returns set in. This is shown as point X in figure 5.4, which is right here, and corresponds to point B in figure 5.3 and point M in figure 5.2. Thereafter, marginal cost rises as the MP falls. Additional units of output cost more and more to produce, since they require ever increasing amounts of the variable factor. Average variable cost now, the shape of the average variable cost curve depends on the shape of the what? APP curve, average physical product curve. As the average product of the workers rises, of the point C as in shown in figure 5.3, which you have seen before, you should have drawn it already. The average labor cost per unit of output falls. In this case, it's average variable cost, right? As far as point Y in figure 5.4, right here. Thereafter, as APP fee falls, average physical product falls, average variable cost what? Must what? Rise. Alright. This simply this is simply the vertical so average total average cost now. This is simply the vertical sum of the average fixed cost and the average variable cost curves. Note that as AFC gets less, the gap between AVC and AC what? Narrows. Look at relationship between average cost and marginal cost now. This is simply an illustration of the relationship that applies between all averages and marginals. As long as the units of output cost less than the average, the production must pull the cost down. Again, as long as new units of output cost less than the average, the production must pull the cost down. That is, if marginal cost is less than average cost must be what? Falling. Likewise, if new units cost more than the average, the production must drive the average up. If marginal cost is greater than average cost must be what? Rising. Therefore, the marginal cost crosses the average cost at its minimum point. Again, the marginal cost what? Crosses average cost as is what? Minimum point. Point Z in figure 5.4. Since all marginal costs are variable, the same relationship holds between what? Marginal cost and average fixed cost. Thank you very much for watching.